In section 4.3, we will multiply and divide radical expressions with binomials. The goals of the lesson are to be able to multiply binomial radical expressions and also divide binomial radical expressions. So each of the following is asking us to divide with radicals. We're going to follow the same process that we did in section 4.2. First thing we'll look for is anything perfect. So in number 1, when I look at the different radicals here, I do notice right away that the square root of 4 is going to turn into 2. So if I rewrite this so that I get 1 plus root 3 over 2, then I'm going to look for, well, does anything else simplify? Nothing else will simplify here. The other thing I'm looking for is, do I have a radical in the denominator? And I don't. So at this point, I know that this is going to be an acceptable final answer. In number 2, there's nothing perfect. Also, I'm looking to see if anything reduces. Well, in order to reduce, I would have to be able to take the same thing out of all 3 parts here, and they would all have to have a radical or all have to be outside of the radical. So in that case, I can't even reduce anything. This is not an acceptable final answer because I have a radical in the denominator. So what we'll want to do here is multiply the top and the bottom by root 2. And the reason we're choosing root 2, again, because this is a square root, my only option is to multiply by a square root. Also because it's a square root, we're looking for pairs of the same number. So if I already have 1, 2, I need one more in order to take that outside of the radical. So in the numerator, I'm going to have to distribute that root 2 into both. That's going to give me 3 root 2 minus root 10. In the denominator, I'll get root 2 times root 2, which will turn into root 4 and then eventually turning into 2. Root 2 times root 2, which gives me root 4, and the square root of 4 is 2. And that right there is my final answer because again, nothing simplifies. I'm looking at 3, -1, and 2. You can't divide all of them by the same thing, and neither of these radicals can break down. Also, I don't have a radical in the denominator, so that confirms that this is an acceptable answer. For number 3, same thing. I tried to look for something perfect. I also look for something that would reduce, and neither of those situations happen here. So now I'm multiplying top and bottom by, I'm going to have to use a square root. And again, because this is a square root, I'm looking for sets of 2 of the same thing. So I already have 1 5, I want another 5, root 5. I already have 1 5, so I want another 5. So when I multiply top and bottom here by root 5, I'm going to distribute that root 5 to both, and that's going to give me root 10 plus root 35 in the top. In the bottom, I would get the square root of 25, which then turns into 5. Once again, if I'm looking to see what can reduce here, since 5 is an outside number, the only way it can reduce with anything is if the outside number in front of root 10 and also in front of root 35, if all 3 of these parts could reduce, then I could reduce it further. But in this case, I cannot go any further. Now, when we get to these expressions, it's a little bit more challenging. I cannot just multiply top and bottom here by root 2. If I were to multiply the bottom here by root 2, I would get, as I distribute it in, I would get 3 root 2 minus 2. And so I still have the same problem then. I would still have a radical in the denominator. So in section 4.2, we worked with a specific type of multiplication, which would get rid of our radicals. And that's when we multiply conjugates. So when we notice that we have a binomial expression in the denominator, we're going to want to multiply that by another binomial, which is the conjugate. So I'm going to choose to multiply by 3 plus root 2 in the bottom, and whatever I do in the denominator, I have to also do in the numerator. In the numerator, I end up distributing this root 2 in, giving me 3 root 2 plus root 2 times root 2 is root 4, which then turns into 2. Then in the denominator, if I multiplied this out, I get 3 times 3, so that's 9. On the outside, I'd get 3 root 2. This part would give me -3 root 2, so those are going to cancel. Then I've got negative root 2 times root 2, which is negative root 4, and ultimately turns into -2. Now 9 minus 2 gives me 7, and that's why this is the final answer. For number 5, once again, I'm looking for things that are perfect. I'm also looking for things that reduce, and neither of those are going to happen here. So here, again, because it's a binomial, I have to multiply by a binomial. And I multiply the conjugate, which is 1 minus root 2. In the numerator, I can distribute that negative root 5 in. That's going to give me negative root 5 plus root 10, because that negative times negative is positive. And then divided by, well, here 1 times 1 is 1. The outside would be negative root 2. The inside would be positive root 2. Those will cancel. And then finally, root 2 times negative root 2 is going to be negative root 4, which then turns into -2. So here 1 minus 2 gives us negative 1. And that's still not the final answer because here if I look at all my outside numbers, I've got a negative 1, a positive 1, and a negative 1. We do not want to leave a negative in the denominator. So I'm going to change this one to a positive 1. And if I want to change the bottom one, I have to change both of the top ones. Therefore, this is going to become positive root 5 minus root 10 as the final answer. Then for number 6, we'll go ahead and multiply this one by 4 plus root 5 as well. Here, if I distribute that root 7 in, it gives me 4 root 7 plus root 35. In the denominator, when I multiply, I've got 4 times 4, which is 16. I could do this would be 4 root 5. This would be negative 4 root 5. They will cancel. Then if I do negative root 5 times root 5, I get negative root 25, which is going to be negative 5. Combining these together is going to give me 11, so that my final answer here is 4 root 7 plus root 35 all over 11. In number 7, we're going to do the same thing. So one thing to keep in mind here is, again, I cannot simplify this because 4s cannot cancel here unless I can take a 4 out of this one, this one, this one, and this one. I cannot simplify this. Once again, I have that issue where if it's a binomial in the denominator, I will have to multiply by its conjugate. So that is going to be 4 minus root 3. What I do to the bottom, I also do to the top. Now the top part, these are not conjugates, so I cannot just do the first and the last part of this. I've got to do the whole thing. 4 times 4 is going to give me 16. 4 times negative root 3 is negative 4 root 3. On the inside, this part right here, negative root 3 times 4 is negative 4 root 3. And then finally, negative root 3 times negative root 3 would be positive root 9. And since root 9 turns into 3, it is going to be positive 3 here. In the bottom, 4 times 4 is going to give you 16. Root 3 times negative root 3 is going to give us negative root 9, which then turns into 3. So to simplify that, I can combine 16 and 3 to give me 19. Negative 4 root 3 and negative 4 root 3 will be negative 8 root 3. And in the denominator, 16 minus 3 is going to be 13. In number 8, we have the same issue. We're going to multiply top and bottom here by 2 minus root 7. In the numerator, when I multiply that, I have to multiply all 4 parts. I'm going to start with 1 times 2, which is 2. Then I'll do 1 times negative root 7, which is negative root 7. Then I do negative root 5 times 2, which is negative 2 root 5. Then negative root 5 times negative root 7, which is positive root 35. And none of that breaks down and none of it combines. In the denominator, 2 times 2 is going to give me 4. I could do the outside, which would give me negative 2 root 7. I could also do the inside, giving me positive 2 root 7. And I could do root 7 times negative root 7, which would give me negative root 49, which then turns into a negative 7. So from here, I've got 4 minus 7, and that means my denominator right now is negative 3. But once again, we're not allowed to have a negative in the denominator. So what we'll do here then is change every single sign in this whole expression. And that's going to make this a negative 2 plus root 7 plus 2 root 5 minus root 35 all over positive 3. And now for number 9. Here, again, the issue is with 1 minus root 7, so we're going to multiply that by 1 plus root 7, top and bottom. In the numerator, as I double distribute, I get root 7 times 1, which is root 7, then root 7 times root 7, which is going to be root 49, and then it turns into 7. Negative 2 times 1 is negative 2, and then negative 2 times root 7 is negative 2 root 7. In the denominator, I've got 1 times 1, which is 1. The outside is 1 root 7, the inside is negative 1 root 7, so those cancel. Then finally, negative root 7 times root 7 is going to be negative root 49, which then turns into negative 7. From here, as I go to combine, 1 minus 7 is going to combine to give me negative 6. And then finally, we want to pay attention to the fact that we're not allowed to have a negative in the denominator. So once again, we're going to change every sign within this whole expression, and it's going to make it negative root 7 minus 7 plus 2 root 7 all over 6. And then the last part here is that we do have some things that can combine. Negative root 7 and 2 root 7 can combine, and also negative 7 and positive 2 can combine. So your final answer here should end up being negative 5 plus root 7 all over 6. Now your homework for section 4.3 will be in Delta Math. 2 of the sections are on multiplying radical binomials, and 2 of them are on rationalizing binomial denominators.